Hello friends, I am Chandan. So in previous lecture we see that the Mach number. Now in this lecture we'll understand the viscosity of the fluid. So it is a property of the fluid which defined the internal resistance between two adjacent layer in relative motion. So this is very important. Remember this, the internal resistance between two layers is known as the viscosity of the fluid, and this viscosity is caused due to cohesive forces. Cohesive force means there is the same molecular attraction, okay, between the molecules, okay, in liquid. And for gases, the molecular momentum transfer in perpendicular direction between two layers. So for gases, the molecular momentum transfer in perpendicular direction between two layers. Okay, so viscosity or dynamic viscosity or absolute viscosity. So viscosity have different type of name. You can say that this is a dynamic viscosity, or you can say that this is absolute viscosity. For liquid, if you say for liquid, so here this is the solid surface here, and the fluid is flowing on the solid surface. Okay, so this is the at y location. At y location, the velocity of the fluid element u, and at y plus dy location the velocity is u plus du. So here the one layer is attracted between the another layer. So this is known as the viscosity. The resistance between two adjacent layers. So this is the one layer and this is another layer. The resistance between two adjacent layer is known as viscosity of the fluid. Okay, so mu created due to cohesive forces, because there is a cohesive means there is a same molecular attraction is there. So that is why mu created between two adjacent layer. And for gases, that is at y location the gases have the velocity u, at y plus dy location u plus du. So here the mu gas created due to the molecular mixing. So that is very important. So for mu gas created due to the molecular mixing. Okay, now so if you see on the liquid, for liquid, so if the cohesive forces decreases for the liquid, so if the liquid have viscosity decreases, then the cohesive force must be decreased, and then that means the shear stress increases. Okay, okay, so if the shear stress increases, then cohesive force decreases, then viscosity also decreases. Okay, and for pressure, if the pressure increases for incompressible fluid, the viscosity is not changes for liquid. Okay, because viscosity is not equal to function of pressure. Okay, and for gas, mu of gas, that is proportional to Vrms. Okay, that is proportional to under root T. So if T increases, then mu gas increases. So we know that from kinetic theory of gases, Vrms, that is equal to under root 3 RT by m at T equal to constant. So Vrms, that is proportional to under root T. So Vrms, that is equal to under root 3 PV by m. So now this is R is the Reynolds number. Reynolds number is the ratio of the inertia force to the viscous force. So inertia force, that is rho v LC. LC is the characteristics length, and v is the velocity, and rho is the density, by mu is the viscosity. So this is the ratio of inertia force by viscous force. So this is very important. If the viscosity increases, then Reynolds number decreases. Okay, now there is another viscosity, that is kinematic viscosity. This is very important, and it is also known as momentum diffusivity. So it is denoted by nu, that is equal to mu by rho. Okay, so remember this formula. This is very important formula. So the mu has the unit, that is Newton second per meter square, and density we know that kg per meter cube. So Newton second per meter square into meter cube per kg. So this meter cube is going up, so meter cube per kg. So from here, if you see that this is the meter per meter square per second. So this is very important unit. Remember, this is very important unit. So for a kinematic viscosity, the unit is meter square per second. Okay, now we know that Reynolds number rho v LC. LC is the characteristics length by mu. So that is equal to VLC by mu. Mu by rho, that is equal to nu. So VLC by mu by rho, that is nu. So Reynolds number, that is proportional to 1 by nu. Okay. Now there is another one example is there. Suppose at 1 atmospheric pressure and 20 degrees Celsius temperature, the water viscosity of water, this is the standard case. Just remember this data, that is very important. So viscosity of water, that is dynamic viscosity of water, that is equal to 1 into 10 to the power minus 3 Newton second per meter square, and viscosity of air, that is 2 into 10 to the power 5 10 to the power minus 5 Newton second per meter square. So viscosity of water by viscosity of air, that is equal to 1 into 10 to the power minus 3 by 2 into 10 to the power minus 5, that is approx equal to 50. Okay, so remember this data, important data. So viscosity of water is greater than, is 50 times greater than the viscosity of air. Okay, now density of water, we know that what is the density of water, that is equal to 1000 kg per meter cube. So if you want to calculate the nu of water, that is equal to 1 into 10 to the power 3 nu, that is mu by rho. So mu of water, that is equal to 1 into 10 to the power minus 3 Newton second per meter square. So 1 into 10 to the power minus 3 divided by 1000, that is the density of water. So that is 10 to the power minus 6 meter square per second. So this is meter square per second. Remember this unit, that is the kinematic viscosity unit. And if you want to calculate the nu for air, so air, the density of air, that is 1.23 kg per meter cube. So 2 into 10 to the power minus 5 divided by 1.23. So 16.2 into 10 to the power 6 meter square per second. So we say that is nu of water less than nu of air. And here mu of water is greater than mu of air. So remember this data, very important data. Now so we see that in above we see that liquid are incompressible, so cohesive forces are independent of pressure, that is viscosity of liquid is independent of pressure. Very important, viscosity of liquid is independent of pressure. Second, the viscosity of gas is defined by root mean speed of molecule, that is molecules, that is randomness at moderate pressure for constant temperature. As pressure increases, volume of the gas decreases, so PV remain constant. Okay, that is viscosity is independent of pressure. So this is very important. So VRM is, that is equal to under root 3 PV by M, that is equal to under root 3 RT by capital M. Okay, now the last small topic, that is the effect of temperature and pressure on kinematic viscosity. So here there is a kinematic viscosity, that is nu. So for liquid, nu of liquid, that is mu of liquid by rho of liquid. And for gases, nu of gas, that is equal to mu of gas by rho of gas. So nu liquid by, that is equal to, so if, so density of liquid does not change. We know that for liquid are incompressible for water. So if viscosity decreases, then what is happened? Decrease due to the cohesive forces. Okay, so if temperature increases, the viscosity decreases, and if the pressure increases, the liquid, if the pressure increases, the viscosity does not change. So kinematic viscosity does not change. Okay, so mu is does not change, rho does not change, so viscosity does not change. So if V increases for liquid, mu, there is no effect, does not change, and nu, that is mu by rho. So here for liquid, if you increase pressure or decrease the pressure, then the viscosity, that is kinematic viscosity, does not change. Okay, and if you increase the pressure, so if you increase the temperature, then the cohesive forces decreases, so that is why viscosity decreases. Okay, so viscosity decreases, so that is why kinematic viscosity, that is decreases. Okay, and for gases, mu of gas, that is mu of gas by rho of gas. So mu of gas, that is equal to mu of gas by rho of gas, so that is proportional to under root t divided by rho of gas proportional to 1 by t. Okay, so mu of gas, that is equal to mu of gas proportional to under root t, rho of gas, that is proportional to p. So for gas, as the temperature increases, that mu is also increases, okay, from this formula. And if the mu is increases, the nu of gas is also increases. And for gases, if the pressure is increases, mu does not change, okay, and nu is decreases. So here, from if the pressure is increases, from this formula the pressure is increases, then nu is decreases. Okay, so Pv equal to mRT, we know that. So P equal to rho RT, rho equal to 1 by T. So gamma of gas, so nu of gas, that is equal to nu of gas 3 to the power t to the power 3 by 2. Okay, so t to the power 3 by 2. So this is all about the effect of temperature and pressure on kinematic viscosity. So this is my handwritten notes. You can download it from the description. The PDFs link are available. You can download it. Thank you.